Good day, ma'am. We are the Group 6.
I am Raymar Colot.
I am Mark Daniel Makatigib.
I am Harold Undang.
I am Joseph D. Lumanog. And today we are about to discuss the topic data organization. What is data organization? Data organization is the practice of categorizing and classifying data to make it more usable. Similar to a file folder where we keep important documents, you'll need to arrange your data in most logical and orderly fashion. So the examples of data organizations are tabular form, graphical form, charts, and frequency distribution.
Tabular form. One of the simplest methods used to analyze the data and to display the data is in a tabular form. In the tabular form, you get a systematic arrangement of rows and columns. The first column is used to indicate the titles in the first row, and the first row is also to indicate the same. This is an example of a tabular form which shows a systematic arrangement of data that is present by rows and columns. So like for example, in the first row, it contains 7 columns. In each column has different indication, namely, employee ID, first name, last name, phone number, hire date, job ID, and salary. In the given example, the first row contains data of the employee ID, which is 100. The first name of the employee, which is 7. The last name of the employee, which is King. The phone number of the employee, the hire date, the job ID, and the employee's salary.
Graphical form. Graphical representation refers to the use of charts and graphs to visually display, analyze, clarify, and interpret numerical data, functions, and other qualitative structures. This is the example of a graphical form. This chart will determine how many favorite sports of students at an international school. As you can see in the left side, you can see the number of students. In the bottom part, you can see the sports that are favorite to students. The blue line represents boys and the pink line represents girls. So in the football sport, the boy is higher than the girls. Let's assume that there are 32 boys whose favorite sport is football and 17 girls whose favorite sport is football. Next is the field hockey. This time, the girl is higher than the boys. Let's assume that there are 9 boys whose favorite sport is field hockey and 13 girls whose favorite sport is field hockey. The same goes to the other sports. So this is how we use the graphical form chart.
Charts is a graphical presentation for data visualization, in which the data represented by the symbols such as base in a bar chart, lines in a line chart, or slices in a pie chart. Examples are pie chart, bar graphs, histogram, ogive, Pareto chart. Pie chart. A pie chart is a circular statistical graphic which is divided into slices to illustrate numerical proportion. In a pie chart, the arc length of each slice is proportional to the quantity in represents. This is the example of a pie chart. Pie chart. You can use the concept of a pie chart by gathering data. In this example, it shows the data gathered of every subject that is favorable by the students. So first, mathematics has 108 degree, science has 81 degree, social science 45 degree, English 72 degree, and Hindi has 45 degree. So in the given data that is shown through the pie chart, we conclude that mathematics has the highest preferable subject, followed by the science, and then English, then Hindi, and lastly, the social science. bar graph. A bar graph can be used as a graphical representation of data, quantities, or numbers using bars or strips. They are used to compare and contrast different types of data, frequencies, or other measures of distinct categories of data. This is the example of a bar graph. So, bar graph is also considered as an example of data gathering, the same as pie graph, but the graphical display are shown as horizontal or vertical bars. Histogram. Histogram is a graph used to represent the frequency distribution of a few data points of one variable. Histograms of bin classify data into various bins or range group and count how many data points belong to each of these bins. This is the example of histogram. So a histogram is also an example of an data gathering, and it almost looks like a bar graph, but the difference is two range group. Like for example, first range is the number of students and the second range is the percentage score.
Ogive. The ogive is defined as the frequency distribution graph of a series. The ogive is a graph of a cumulative distribution which explains data values on the horizontal plane axis and either the cumulative relative frequencies, or cumulative percent frequencies on the vertical axis. This is the example of ogive.
Pareto chart. A Pareto chart is a type of chart that contains both bars and a line graph, where individual values are presented in descending order by bars, and a cumulative total is represented by the line. Here is the example of a Pareto chart. Notice the presence of both bars and a line on the Pareto chart. Each bar usually represents a type of defect or problem. The height of the problem represents any important unit of measure, often the frequency of occurrence or cause. The bars are represented in descending order, from tallest to shortest. Therefore, you can see which defects are more frequent at a glance. The line represents the cumulative percentage of defects. Let's look at the table of data for the Pareto chart above to understand what cumulative percentage is. So the bottom defect, there are 3, 39, 39. Pocket defect, 16, 57.1, 66.1. Color defect, 10, 16.9, 83.1. Cuff defect, 7, 11.9, 11.9. Sleeve defect, 3, 5.1, 16.9. Total of 59. For color defects, the percentage of total is simply 10 over 59. The cumulative percent corresponds to the sum of all percentage previous to and including color defects. In this case, this would be the sum of percentages of bottom defects, pocket defects, and color defects. So 39% plus 27.1% plus 16.9%. The last cumulative percentage will always be 100%. Cumulative percentage indicate what percentage of all defects can be removed if the most important types of defects are solved. In the example, solving the two most important type defects, bottom defects and pocket defects, will remove 66% of all defects. In any Pareto chart, for as long as the cumulative percentage line is steep, the types of defects have a significant cumulative effect. Therefore, it is worth finding the cause of these types of defects and solving them. When the cumulative percentage line starts to flatten, the types of defects do not deserve as much attention, since solving them will not influence the outcome as much.
Lastly is the frequency distribution table. A frequency distribution table is a method to organize the data given so that it makes it more meaningful and easier to understand. A frequency distribution table has 2 or 3 columns. The first column has all the outcomes as individual values or in the form of class intervals. The second column of the table includes tally marks of each outcome, which also tells us about the frequency using vertical lines. The third column tells us about the frequency of each outcome. For example, Alan has to put some footballs into 2 boxes. He starts dropping one football after the other into 2 boxes named A and B. Alan drops the balls randomly. And after dropping 10 balls, he takes some rest and then repeats the task with the remaining 10 balls. So as you can see in the given tables, that shows the pattern of how Alan drops the football in 2 boxes. So as you can see in trial 1, his first attempt, the ball drops in box A. His second attempt, the ball drops in box B. The third attempt, the ball drops in box A. The fourth attempt drops in box A. Fifth attempt, box A. Sixth attempt, box A. Seventh attempt, box B. Eighth attempt, box A. Ninth attempt, box B. And lastly, the 10th attempt falls into the box A. And as what in the situation said, he takes some rest and then repeats the task with the remaining 10 balls. So in the trial 2, his first attempt, the ball drops in box B. Second attempt, box B. Third attempt, box A. Fourth attempt, box A. Fifth attempt, box A. Sixth attempt, box A. Seventh attempt, box B. Eighth attempt, box A. Ninth attempt, box B. 10 attempt, box A. In order to find the frequency of a ball falling in box A, so we can use both the trials in the 2 tables. So in trial 1, the frequency of balls dropping in box A are approximately 8 balls. So in trial 2, there are 6 balls dropping in box A.